In section 14.7, we turn our attention to Jointspace record and playback nodes. The Baxter robot can easily be taught by demonstration. When pressing his cuff, Baxter enters a lead-through mode. Replaying of recorded trajectories can easily be done. From this video from Rethink Robotics, you can see how this gentleman is pressing the cuff of both of these robots, and when that is done, all of the motions of the robot are being recorded, including the opening and the closing of the gripper. After a trajectory has been taught, it can easily be replayed to repeat the motion, like so. From the Rethink Baxter code, there is a Python teach and playback example that you can access here. We will be looking at the C++ equivalent in the source code of our book. A number of files that we will use in this section are found in the Baxter play file nodes package. The first file that I want to introduce to you is the get and save joint values.cpp. It has the equivalent get and save joint values node. Here, every time you can save a joint configuration when you enter a 1 into the screen. So basically you move the arm to a desired location, and wherever you want to record a waypoint, you can enter number 1 into the screen where the program is waiting for user input, and that will be a waypoint recorded by the system. When you want to finish all recording, a 0 can be entered, and this will save joint configurations to a file that has a torso to wrist order for the joint angles and a file with a text extension. A second file that is interesting is the Baxter record trajectory.cpp, or Baxter recorder node. Here we can enter 1 to start recording, and all motions are recorded continually. The difference with the previous file is that joint configurations are also saved with a timestamp. So this will reflect not only the position but also the velocity with which the motions were saved. Files with this CPP are written to a file with a JSP extension. When in simulation, an arm can be moved by using, for example, this joint position keyboard Python script, also part of the Rethink Robotics package. So let me give you a demonstration of that. So down here, let me make sure that this terminal is enabled. We can use Baxter examples and joint position keyboard.py. This simple program, which you can find on their website, will allow you to use, you have to click on the terminal. You have to use the keyboard like numbers 1 and 5 to move this first shoulder, 2 and 4 to move this shoulder, Q and R to move this elbow joint, and then E and W to move this elbow joint, and so forth. So now we might be ready to come here to the Baxter playfile nodes package and run Baxter recorder. That is Rust run. So at this moment, we start capturing, and then here we can start the motion of the robot. Like so. Once we're ready to terminate with this motion, we can press Control C, and this file, or two sets of files, are recorded here. Baxter left arm trajectory.jsp and Baxter right arm trajectory.jsp. Additionally, pre-recorded trajectories from a real Baxter can also be found in the same package. Now notice all the files that we included here. For example, we have a hug JSP, arm slide JSP, pre-pose left JSP, scratch, shake, stick, wave, shy. Any of these files can be run by having all of the following commands, making sure that Baxter Worlds launch is run, that the Baxter robot is enabled by starting the joint trajectory action server from the streamer package, and then moving to the Baxter play file nodes location, from which then the Baxter play file nodes package Baxter Playback node can be called. So let's try to get all of that running. I believe our robot is enabled, so Baxter trajectory streamer, right arm, left arm. Here I'm already in the play file nodes package, and I might be interested in running this file for my right arm. Baxter play file nodes, and then this is, let me double check, Baxter Playback. So if we do this, we should see the original file that the original motion that I asked the robot to execute. So you can see all of these motions that I commanded earlier. So I hope you find this very interesting technique to move the robot in some interesting way. Now let's explore other files that might be interesting. So let's take a look at the arm slide. Here it is, the sliding of the robot arm. We can try can grasp pose. Which might be in the same location. We can try the pre-pose. And then the can grasp one more time. Like that. We can also try shy. Where the robot covers his eyes. And so as I run more of these examples, you can see that this might be useful in many applications where a pre-recorded motion of some type has been saved into a database, and a particular motion you may want to retrieve a particular kind of motion. There's other kinds of files that will allow us to play the files as well. This is the Baxter play file jointspace.cpp is exactly what we ran right now. The main method here, read trajectory file, has an argument for the file name and then an out variable for the trajectory. So this will read the 7 joint angles and the arrival time, and then create a trajectory messages joint trajectory object for the right arm and optionally for the left, and then populate a trajectory for the object. Now there's something very important here that we must pay attention to. The current position of the arm may be far away from the first point in that file. If that is true, then it would be easy for the robot to experience a wild motion from the current position to the first point. So it is very important then to measure this distance and compute an approach trajectory that is able to connect the current angles of the robot to the first point in the file. In our code, this path is converted into a trajectory using the Baxter Streamer package and then a method within called stub trajectory right arm. You can click on the link to find the exact place where that is defined. One more file which is of interest is this Baxter multi-trajectory player.cpp, and instead of asking us to write the file name on the command line, the file name can be published onto a topic called play file codes. Moreover, the way we provide the name for a topic is simply through an encoding of an unsigned integer for pre-saved files. So if you had an established database, you could simply assign each file with a number and then just publish that topic. And another aspect of the code that is interesting is that it can use the ROS workspace environment path to more easily compute the path of the files that are located in our package that we're using right here. Please click on the link to look at the details for this file. Finally, to facilitate the running of the teach and playback services, there's also a launch file that we have created that has a useful set of programs. So number one, it enables the Baxter robot through the Baxter Tools Enable Robot script. It also starts the Baxter Trajectory Streamer for the right and the left arms. It will also open RViz with a pre-configured file showing us the frames of the robot. It will originally play the pre-pose right and left JSP files such that both of Baxter's arms are in good starting positions. And so this simple launch file will do all the heavy work that I showed earlier. The file doesn't start the Baxter gazebo node, so that's something you would need to start doing at the beginning. Then by launching the Baxter play file nodes launch file, you can get the robot ready to take any of the pre-recorded trajectories.